model too. Special Topics 2, Test 1. This is where we're talking about these hybrid vehicles here. Everybody, listen up and shut off the private conversations. Listen up. GM Electric Vehicle 1, EV1, was what type of vehicle? Do you remember?
I have no idea.
That particular one was totally electric powered. Ford made some fully electric Ford Rangers back in the 90s. And they were actually really interesting to me because one day the parts guy stumbled across a battery for one of those fully electric Rangers. And it basically, the underneath the bed was the big battery that operated the thing. You charge up like a plug-in. And most people didn't even know about those, but they built them for use in the cities, like for municipal cities, you know, pardon me, like big cities. And you could lease one, but they wouldn't let you have it when the lease was up. You had to get it back to them. And it was like $18,000 for a battery for those, really something. What kind of hybrid is capable of propelling the vehicle by using just the electric motor? That could be a medium hybrid, a BAS type, a strong hybrid, or a mild hybrid.
Mild.
It's going to be a strong hybrid. It's a full hybrid, just using the electric motor. Okay, now you guys understand that. I want to mention this right quick on the ones that the Fords and the Toyotas are very similar in the way that they do their. They got them two motors in the transmission. The Honda is a different creature. And I basically need to give you guys some information on that too. Imagine on a Honda car, and you know, Honda was pretty slick about the way they did that. They basically put the electric motor in between the engine and the transmission. It's like a wafer thing about this thick in between there. It's got it's got the batteries in that one look like a bunch of flashlight batteries, and I can show you guys some video stuff I got on that, which is pretty cool. But that thing is basically, imagine that battery, that motor between the engine and the transmission being like an electric supercharger. It just helps, you know, that kind of thing. So just kind of keep that in mind. And also the Honda has got a regular starter on it, just like any other car. So if you decided you wanted to drive particularly on the older ones, those little Honda Insights, if you decided you wanted to drive it like a regular car and you didn't want to use the hybrid, you could do that. You could crank it up and drive it around, you know. And so... All right. How fast does a motor generator crank the internal combustion engine? If you got the motor generator is the motor of the two in the Toyota/Ford type, and I'm just classifying them that way. It's gonna, and you remember how those are hooked up? Well, we looked at, some of us that were here early looked at some video stuff from that I showed you earlier. Do you remember which motor is hooked to what? You got three different engines hooked to three different parts of the planetary gear set. What are the parts of a planetary gear set? And this is on the Ford/Toyota kind. The three kinds of a planetary, and even in an automatic transmission, guys, what's the parts of a planetary gear set? Sun gear, carrier, ring gear. The carrier's got the little planets. The sun gear's the gear in the middle. The ring gear's one on the outside. Okay. Okay. So what is it that's hooked to the planet carrier on a hybrid vehicle? On the hybrid vehicle, this is the Ford/Toyota kind. The engine, remember this, the engine is hooked to the carrier. You got me? The engine is hooked to the carrier. Always remember that. That's bolted to the engine. Okay, the sun gear is hooked to the little starter generator, and the big motor that drives the vehicle down the road is actually going to be hooked to the ring gear. So you got a motor hooked to each one of the components, like the sun gear and the ring gear are hooked to electric motors. Remember, the sun gear is smaller than the ring gear, right? As far as diameter, that's the way I remember that. Toyota calls the small one MG1 and the big one MG2, I think, as far as the motors, you know. But so this is something else I want to say while I'm still thinking about it. In order to give you all of your different ranges and all that, there are times when the electric motor has got to turn backwards. The electric motors could be turning in either direction, depending on which range that you're going to, because the continuous variable transmission in one of these is centered around the planetary. And I can actually show you a really good, I've got that here, I'm going to plug it in, I may show that in a minute. The way that it works, you'll see them gears working whenever the motor can drive, the little starter motor can drive the engine. How would you do that? I'm going to hold the sun gear and I'm going to drive I'm going to hold the ring gear and I'll drive the sun gear with a little starter generator, and that's going to spin the engine, right? Because what's the engine bolted to? The carrier. So think of the planet gear is bolted to the engine, the sun gear is bolted to the starter generator, and then your bigger electric motor, which is like an 88 horsepower motor, is actually bolted to the ring gear. So just keep that in mind. Focus that on, burn that in. You raised your hand a minute ago. What was that about?
Are the continuous variable transmissions, are they better than like the regular ones?
I think they are as far as keeping the power curve, because you've got an infinite number of ranges. You know, now there's issues that they can have with them that you don't have with a regular transmission.
Yeah, because I know they got them, or I know they're in a lot of the Altimas.
Mm-hmm. And they're also in Muranos. They've got them.
I know a lot of people, some people don't like them.
Yeah, I know. It just depends on what you're used to.
I mean, yeah. I mean,
but now these hybrids have got continuous variable transmissions in them, because you know you're shifting gears on those. But anyway, let's see. So number 3, once again, stop throwing stuff, guys. You're not in high school anymore. How fast does a motor generator crank the internal combustion engine? Anybody know? We talked about it the other day. Some of y'all were here. You'll think the engine's running if you hear that motor spinning it, because it spins about 1,000 RPM. How fast? Webb, I asked you this the other day. Webb, look at that. I'm going to ask you, what was that? How fast does the regular starter spin the engine? Remember? 175, 200 RPM. This starter generator is going to spin at 1,000 RPM. That's faster than it idles on a regular clock. And you may hear that thing spinning and think it's running. Remember? Well, all right, now, which type of electric hybrid vehicle has idle stop operation? Strong, mild, and medium hybrids. All of them do. Jimmy said this guy came in there, a GSA employee the other day, government employee, was driving a hybrid vehicle that belongs to the government. And he brought that government vehicle in for work, because he said when he pulled up to stop, the engine would die. Now, what's wrong with this picture, you know? Okay, number 5. Matt, look this way. You don't need to be looking at other guys. Technician A says most hybrids require they be plugged into an electrical outlet at night to provide the electrical power to help propel the vehicle. Is that right, or is that wrong? That's the technician A and B. What is it? Are you going to plug a hybrid in so to provide plug-in hybrids? But most hybrids nowadays aren't plug-in hybrids. There are plug-in hybrids out there. Most of them aren't. Technician, huh? Yeah, technician B. Let's read technician B. Technician B says the internal combustion engine in an HEV will often stop running when it stopped. He's right.
What does HEV stand for?
Hybrid electric vehicle.
Okay.
So the engine just completely shut off?
Yeah, just completely shut off. As a matter of fact, it's a strange thing if you haven't driven one. What you're going to do, like let's say you get in a Ford Escape, you know, like a 05, 06 Ford Escape. You turn the key and start the engine just like you ordinarily would. And as soon as you let off the key, the engine stalls. And you put it in gear, and you put your foot on the accelerator, and it drives off like a golf cart. No engine running. But if you get out here, let's say you get out there and you need to get in it. I was driving one back when I went to school up there with that noise, vibration, and harshness. He had a one out there, and I said, let me drive this. And so he says, all right, let's go. So we got in it, and there's no noise. It's just totally quiet. It's kind of spooky if you're not used to it. So I get out there and I said, okay, this thing got any power? He said, get on it, like you were having to get in traffic. And when I got on it, just the instant that I pushed that gas pedal, the engine started up, and that thing just threw you back in the seat like a hot rod. But the engine starts up when it needs it. If you're running the engine on max AC, it's going to run all. I mean, if you're running AC on max AC, the engine's going to run all the time because it has to maintain that and all that. But now I'll tell you something else that I need to tell you about a hybrid. On most of them, if you run out of gas, you're not just going to drive a while on your batteries, because you'll kill them batteries real fast driving just on a battery. Now the Ford Fusion, when it came out in 2010, the claim to fame that it had was it could go 1.5 miles at 50 miles an hour just on a battery, which sounds like not much distance, you know, really. And on the Toyotas, initially, whenever they came out, if you ran the battery low enough, you had to get a special battery charger shipped from Japan and loaned out to you to charge the darn thing back up. Well, what Ford did was they had a little thing that a little button you could push, and it would change the circuitry. So the 12-volt battery, and all of them got 12-volt batteries too, you know, because your 12-volt battery is going to be running your dash and your, you know, radio and all that hogwash. You don't want 330 or 400 volts running this stuff inside the car. So you got a regular battery, and it's actually charged by the DC to DC converter, you know, so that you're going to, and back there in the back, when you turn on that thing, and the big battery engages, you got contactors that slap together, kind of like on, you know, these air conditioners. You have these big contactors go thunk, you know, that's how that works. It has to happen really fast and really positive, because if they came together slow, it'd be like a welding machine, just burn them up. So they got to make it slap together quick. And the negative part of that big battery is not grounded to the frame on the car at all. It's totally isolated. And it's constantly, the computers are constantly checking to see if there's any kind of a breach in those cables. The orange cables are the ones that are going to carry your high voltage. You see what I'm saying?
So you said a full hybrid runs totally on electric?
Yeah, the full hybrid basically can run on electric. It can run fully on electric, but it's not going. You're not going to drive around all the time on electric. But in town, you'll get better gas mileage in town than you will on the road on a hybrid. And the reason is more of the time you're going to be pulled by your electric.
So is there a switch?
It's all automatic.
Automatic.
Yeah, it makes that decision. You don't. You know, typically it's going to be what decides. And these are general principles. But you're going to start it up. It's going to be monitoring its voltages, and it knows when it needs power. When you hit the brake, it's going to use that kinetic energy. It energizes that little starter generator, and it's going to use you know how when your alternator pulls the engine down when it starts putting out? All right, this thing right here has resistance too. And since it's hooked to the, you know, it actually hooks everything up so that when you hit the brake, the first thing that happens is it turns that starter generator into something that's going to start slowing the car down, and all that momentum of the car is going to drive voltage, create voltage, and run it back into the battery, and it's going to help charge your battery up. It's cool as all get out the way they got them going on. But I will tell you, it's real expensive to build these dadgum things, you know. All right, so, but they're improving them all the time. So number 5 is basically going to be B. Number 6, Technician A says most hybrids use a series hybrid design. Technician B says some hybrids have 42-volt batteries. Who's correct about that? D. Neither technician is right about that.
Oh, really?
Yeah. Electric motors.
The high volt batteries would be used.
Huh?
Well, I thought we were talking about like straight, fully. I was thinking straight full. Like
So what is that series hybrid design?
Yeah, if you look at, did you get your book yet? Some of this is for your study in your books.
When we look at the volt.
Dig in your book for your automotive. I mean, I don't know if I got one right here or not, but look in that book, and it's gonna the book you're getting on hybrid and alternative vehicle. I mean, that's where you're gonna do your study. See what I'm saying? So you guys get that. How many of you guys does not have a book for this hybrid course?
I have a question.
Yeah. Huh?
You know the new Volt? Who's that made by?
Chevrolet.
It's not new anymore.
Yeah, it's not new anymore, but.
Cost $90,000 to build it, and they sell it for about $42.
Alright,
Typical government stuff, you know. So.
Wait, what?
The battery in that thing is huge.
Yeah, it goes all the way from the front to the back of the car.
What volt was
And it's liquid cold. It's probably like 500-600 volts. I don't know. I've got that around here somewhere, but I do know that they had problems with them catching fire, and they had to liquid cool them and all that. You know, I mean, you can go to the Chevrolet dealer and they'll show you one and ride you around in it if you'll look at it. It ain't complicated. They'll give you little flyers on it, all that kind of stuff. It's pretty cool. Now, I will tell you how that works. You got a 3-gallon gas tank. So if you just want to drive around with the engine and never use the electric, you're just fine, but you're going to be filling it up every time you burn 3 gallons of gas. But see, they do have it where you can drive it without having a battery. See, on that one. It's basically a fully electric, and a Nissan Leaf is kind of similar to that.
The thing, I don't see the point in those around here. Because you don't really have a place to charge them up at your house.
Yeah, well, you can charge them up at your house, you know. They actually have a charging station you can get, you know, charge them up quicker. But I mean, more and more of that stuff is coming online. Although I will tell you this, if it puts that much of a load on the power grid, it seems like one way or another you burn energy, you know. All right, so let's look at this.
Do they have cars that are like hybrid with like a solar thing on the top to charge the batteries?
That was some stuff that they've been experimenting with, but it don't really work all that well. There's not enough solar and wind and all that kind of stuff to make power, you know, really.
Yeah. Well, I mean, it would help, wouldn't it?
It helps some. I mean, they do have solar panels that are all the way on the top of the car on some vehicles. I don't remember which ones they are, but I've seen that. Technician A says most hybrids use the series hybrid design. And Technician B says those wiper blades are on my desk in there.
Okay.
Yeah, just leave those in there and take those.
old ones?
Yeah, the old ones are on my desk in there.
Wait, one of them or two?
Most hybrids use series hybrid design. Technician B says some hybrids have 42-volt batteries, and that's the one we just read. Electric motors are better than internal combustion engine to propel a vehicle because why?
All of them?
Yeah, it's going to be all the above. They're quiet, they produce high torque at low speeds, they don't burn fuel, and they don't release carbon dioxide. Now, what we got here those little, you seen these Tesla cars? You ever seen a Tesla? Looks like a daggone Porsche or something. I got in one of my videos where I went out there, I walked around that thing. I talked to the guy that was there with them. It's about a $120,000 car. And it's fully electric. There ain't no gasoline engine in that thing nowhere. And because of the fact that those electric motors, they got 225-mile cruising range before you got to recharge your battery. Yeah, if you want to drive to Texas, you're going to be stopping for a while, you know what I'm saying? But one way or another, I says, is it pretty strong? He says, you could probably you'd have to buy a lot of tires if you take off too fast because it'll burn the tire slam off the car. It's because it's instant power. You know, it doesn't have a power curve. I mean, as soon as you want power, bam, you got full power. You know, that's the way that thing works. And it was a sexy looking car too. It looked like a James Bond car. Looked kind of like a Lotus, whatever. Electric motors are better than internal combustion engine because of all that. All the above, or all the following are characteristics of a hybrid electric vehicle, except A, lower amount of carbon dioxide. That's right. B, high voltages. C, lower fuel economy. D, quiet. Which of those is not a characteristic of a hybrid electric vehicle? Is it quiet? Does it have lower fuel economy? That's going to be C, isn't it? All right. All right, you guys start answering some of these. You should know. If you don't have a book, let me know. We need to try to see if we can figure out a way to get you up one. We're early in the semester. We're just getting started. That's why I didn't know.
That technical waiver about covering our books?
I don't think the technical waiver is going to do that.
That's $413.
Yeah. Technician A says a major limitation of electric vehicles is their short range. Is he right? Yeah, if it's a fully electric vehicle, it's not going to have all that much range. Now, that Ford Ranger had a pretty good range on it. You could drive it all day long, but it was a huge, gigantic battery, too. 8 was actually C. Okay. A major limitation of electric vehicles is short range. Technician B says a major advantage of electric vehicles is their quiet operation, and this is that's a no-brainer question. Just put a C down there and go on. Technician A says a diesel hybrid is not possible. Technician B says a diesel hybrid is possible, but is not cost-effective enough for production at this time, and Technician B is the right answer on that one. You can have a diesel hybrid. Number 11, hybrid vehicles operate in the, what's HOV lane? Any idea? Hybrid, not hybrid, high occupant vehicle. So there are lanes in California where you can only ride in that lane if you got like 4 people in the car.
Oh, but they call that, what's called carpool lane.
Yeah, exactly.
Yeah.
Well, I think the state calls it, people call it a carpool lane, state calls it HOV. Okay. But you can, if you're driving a hybrid though, they'll let you drive in there even if you're by yourself.
Mm-hmm.
That's cool. Yeah, if you're driving a hybrid.
What's the catch with that? Why?
Because of the fact that you're not burning as much gas. I mean, it's just they're patting you on the back for having a hybrid.
Wait, so you're burning more gas by going in that lane?
Well, you're basically allowed, since you're not burning as much gas per person in that lane. See what I'm saying? If one person is riding a car, then he's burning a lot of gas to transport himself. So you're talking about how much gas are you burning to transport this many people? So you're basically getting more work done for the same. You know, that's what their thinking is. Yeah. What makes the BAS system attractive for buyers? Battery alternator starter is what that is. Now, you know, it's a crazy thing. We got a great big old motor, starter, generator. You know how a golf cart works? Whenever you, it's really interesting how similar they are to a hybrid, other than the fact that they're not terribly electric. Whenever you put your foot on the gas, the engine starts up and it goes.
Yeah.
You let off, it dies. Well, you got a starter generator on there. Whenever it's running, when you got it on it and the engine's running, the engine's pulling the generator and it's charging the battery. And when you let off, the engine dies. But when you put your foot back on there, the generator is actually turns into a starter and is spinning the engine automatically. And that's what goes on these, the early GM. They'd have a great big old ugly starter generator down here, but a bullet on the side of the block with a big wide belt on it on the front. And when you'd pull them GMs up there, it had like a 36 volt system. They were pull it up there. It had 3 batteries in there behind the seats and all that stuff. The cables on those were blue. And when you pull up there, you just let off and the engine would stop.
Why do the Denali's, the big GMC truck, why they have more than one spot for a battery?
Well, that's because on some of them there was a diesel. That's always, they build them for you put a Duramax in it, you know. And they're going to need 2 batteries. Hey, Alice. Yeah.
Is it in the car?
Well, no, the key's laying in there right in front of my computer screen.
Right beside the office?
Yeah, no, yeah, right in my office. Yeah, just look. You'll see it laying there. I look at my computer and it's laying right there. And all right. Okay. All right. Let's see.
Okay, what was I about to say?
You were about to say something?
Yeah, I heard something.
And you got interrupted by Zach.
It'll come back to me.
Hold that thought. It'll
What
come
were
back
you
to me.
talking about?
We were talking about those starter generators and golf carts. And
Oh, yeah, wouldn't that be kind of dangerous if they started putting those in cars?
What?
Like starter generators where it's just like you gotta press the gas in the car?
Well, no. I mean, you're going to have the thing owned before it's going to do that. But it's in there. I mean, General Motors was doing it, and General Motors has even got a pickup truck that's got 2 big electric motors in the transmission. You know, that's hybrid like that. I mean, it looked like your truck. It's a full-size hybrid pickup truck. All that, but anyway, let's see. The abbreviation. Oh, excuse me. Number 12. Number 12 is C. That's both A and B.
Number 13 is C.
13, the abbreviation for HEV as hybrid electric vehicle, not high energy voltage. Technician A says the full hybrid electric vehicle need to be plugged into a standard AC electrical outlet to charge.
Excuse me again, just one of them is mine, right? There were 2 there.
No, don't take those tickets, just take the key.
Just the key, have
Yes.
you sent the other?
Yeah, I'll fix you up to that work order later, just go ahead.
Finally, I understand, thank you.
Sure, okay, yeah. Yeah, and
He's gonna take it back.
she was trying to take my invoices, huh? A little
Okay, she'll
confusing.
take it anyway.
Yeah. Yeah, well, whatever. All right, let's go here. So, Technician B says the high voltage battery in an HEV uses a generator driven by the internal combustion engine for recharging. B is right about that. See, the internal combustion engine, and what's special about the internal combustion engine in a hybrid, you guys, the ones of you that were here? Remember? What's different about a internal combustion engine, which we're going to call that the ICE, I-C-E, right? If I talk about the ICE, what's different about it than a regular gasoline engine? Some of you guys remember from our video, from our web presentation? It's actually going to be an Atkinson cycle engine, and it operates differently from a regular gasoline engine in that during part of the compression stroke, the intake valves are still open. Ain't that kind of interesting? All right, they do it that way for economy, and it's worked just fine for hybrid vehicles. Okay, number 15. Which of these statements about series hybrid vehicles is true? A, the internal combustion engine turns into a generator to charge a battery. B, the engine never powers the vehicle directly. C, both A and B, or D, neither A or B. And that's number 15. That is C. The internal combustion engine turns into a generator to charge a battery. Turns a generator, not turns into one. And the engine never powers the vehicle directly. See, so basically the engine, and that's sort of going to answer the question that I was going to have you dig up. But the engine is spinning the generator, but it doesn't actually drive the wheels. You got me? And that kind of thing. How does a locomotive work?
I don't know.
Pull a train. What kind of fuel does it use?
Diesel.
Diesel. So what does that diesel engine do?
Create torque, create power.
It spins a generator. Now what does the generator do? The generator drives electric motors that run the wheels. So in a way, if you look at it, a locomotive is a hybrid. It has been ever since there's been diesel locomotives.
Was it electric braking or something?
Huh?
Electric braking?
Yeah, I'm sure. They're not going to have wheel cylinders. Huh?
You're seeing one just like lock it up.
Yeah.
Like you're going to.
Yeah, they're going to be electric and all that. But and I tell you something else that they before they came out with nuclear submarines, that those diesel electric submarines work the same way. They had an engine that ran a motor where they had batteries, too. So they were sort of like a hybrid, So we're thinking about that right there. All right, so let's see. Which of these is not an advantage of a series hybrid design? A, no transmission is necessary. B, smaller internal combustion engine. C, a single speed gearbox can be used. Or D, all of these are advantages of a hybrid design.
You haven't said anything about the transmission, have you?
Well, the transmission in the hybrid has got 2 electric motors and a planetary gear set. And it's got big inverters It takes that DC voltage coming from the battery, turns it to AC voltage to run them motors. So the motors run on AC current, but the current coming out of the battery is DC. So you're going to have big converters, big electronics and all that to do that. But yeah, but transmissions are simple on hybrids, basically. And you know, I was telling you guys the other day, on one of these Toyotas or the Fords, you can tell if the battery, you can tell if the transmission, the motors in the transmission, you can tell if they're bad by pushing the car. If you put it in neutral and push the car, and the car pushes, if it goes like it's hard and easy and hard and easy and hard and easy.
Like brakes on the road.
Yeah. Zach, what are you talking about?
Engine.
Yeah, nothing. Run his mouth. All right. So, which of these statements is true? Let's see. You got that. Not an advantage. Number 16. 16 is D. All of them are advantages. You got no transmission. You got smaller internal combustion engine. Single-speed gearbox. 17. A technician A says in a parallel hybrid design, only the electric motor is connected to the transmission. Technician B says in a parallel hybrid design, the vehicle can be propelled by the electric traction motor, internal combustion engine, or both.
I've never heard of
C.
I've never heard of an electric traction engine.
Well, you have now.
C.
Okay. 17, that's B.
B. Told you to be.
That's B. Electric traction motor.
B.
Got that. Does the gasoline engine start up when you put it in reverse? On these ones that we're talking about? You're always running on electric in reverse. When you put it in reverse, you're always running on electric. Question number 18. Which is a characteristic of many hybrid electric vehicle HEV gasoline engines? A. Variable valve timing and or displacement. B. Offset crankshaft. C. Smaller displacement. Or D. All of the above. That's D. All of the above. A hybrid electric vehicle, HEV gasoline engine, usually uses what viscosity of engine oil? Somebody take a guess at that.
I'm going to say it's 0W20.
Yeah, 19. We're going to have a 0W20.
Yep.
And like I said the other day, don't put any other kind of oil in a hybrid, and also make darn sure you know how to operate the thing. So if you happen to draw an oil change on one, you don't want to happen to have the thing in the air and it see that its battery is low and it decides to start the engine up to charge the battery because you didn't take it out of service the right way. People have drained the oil out of hybrid vehicles and had them start up on the lift without the oil in the crankcase because they don't know that you've drained the oil. They should have an oil sensor in there, shouldn't they? If it doesn't have oil, it shouldn't start.
Yeah.
But then that would malfunction and you would have oil, but you wouldn't think you didn't have oil and it wouldn't start. They'd be calling a tow truck. All right, so let me see here where we're headed. Brake horsepower is calculated using which of the following? Brake horsepower. Torque times RPM divided by 5252.
That's what I was going to say.
I was going to say 2 times 5 times stroke.
Brake horsepower calculated by using torque times RPM divided by 5252. Now, in order to calculate those, you're going to have to know what your torque is. You can figure out what your RPM is by looking at the tach, and you know what 5252 is. The only thing that's skewed that you're not going to know is torque. You know what your torque is. You know, like you fly an Apache helicopter, and it'll tell you what the torque is whenever you throttle it up, all this kind of thing. Okay. Now then, torque is expressed in units of what?
Foot, pound,
This is tricky. Pound feet. Yeah. Anybody ever call that? Anybody ever call that pound feet? That's what it said.
People just look at me funny.
That's not wrong. You can take that big expensive snap-on torque wrench, and if you look at the words on it, it says pound feet. But that's the right way to say it. But people in the real world don't say pound feet. They say foot pounds. You know?
I've never even heard pound feet. I've never heard anybody say that.
I haven't before. Well, one day when I first started teaching here, I said foot pounds forever. And Bo, the guy that was, he was in here as a military guy, he said pound feet. And I said, well, I looked at that torque wrench and it said pound feet. Yeah.
Well, if you look at it like the Newton meters, it's the same thing.
Yeah, it is. Well, like if you look at the way it's written, it's Ulb's foot, pound feet. But we all say foot pounds because that just rolls off your tongue like peas off a knife, you know. All right. So anyway, that's interesting. You can get messed up on that. All right. Horsepower can be expressed in units of what? What is that? Foot pounds per minute. Foot pounds per minute. Okay, 23. Hybrid electric vehicle gasoline engine. Hey, you guys, what are you guys talking about? Jeremy, are you the offender that's causing him to talk? Horsepower can also be expressed in units of foot-pounds per minute, which is crazy. Do you know how you think about those words? Okay, and hybrid electric vehicle gasoline engines often use variable valve timing, returnless fuel delivery, and wideband oxygen sensors, you know, to do that. All of the above. Maximum fuel economy. Atkinson cycle design engine. What about? Tell me about Atkinson cycle engine design.
I got. I don't know that answer. But I got foot pounds and pound feet.
Okay.
It says foot pound and pound feet are the same thing. Be careful when you use the terms like foot pound or pound feet as you did in the title, as these literally mean feet per pound and pound per foot, which are entirely different. Talking about kinetic energy.
Well, that sure cleared that up, didn't it? Okay.
I mean, there's a lot to read here. I don't read it all.
All right, Atkinson cycle, does it require special fuel? Operates differently than the normal four-stroke cycle gasoline engine. Uses the same four-stroke cycle but delays the closing of the intake valve. Both A and B are correct. Which one is it?
C.
That's C. Uses the same four-stroke cycle but delays the closing of the intake valve. That's an Atkinson cycle engine. And a wideband oxygen sensor is used to, what? Help improve fuel economy by allowing the engine to operate at a lean air-fuel ratio. B, helps the engine achieve a super ultra-low emission vehicle rating. C, helps the engine achieve ultra-low emission vehicle rating. Or
Okay.
D, all of the above.
This shows it right here. This is a full explanation example.
All right.
Work is force applied over a distance. If it takes 20 pounds of force to push a box across the floor and you pushed it 20 feet, you did 400 foot-pounds of work. If you pulled the end of an 18-inch, it says 18-inch wrench, with 80 pounds of force perpendicular to the handle, you are applying 120 foot-pounds of torque. By convention, work is expressed as foot-pound, and torque is expressed in terms of pound-foot.
Pound feet.
See, this really clears it all up, doesn't it? Like basically, it's a semantics thing. It's just all whichever you want to say it, you know.
It's weird.
Yeah.
But it says they're entirely different too.
Yeah, it says they're different, then it says they're the same. Okay. I think that we got a lot of confusion going on there.
Read that.
Yeah. All right. Zach don't want to read anything. All right. So.
Yeah, but it was more kind of.
Yeah. Well, whatever. But, all right. Number 25. If you remember that, that's D. That's all the above. Number 26. The use of an offset crankshaft. Why do we use an offset crankshaft? Improves fuel economy but reduces internal engine friction. You know that? It improves fuel economy but reduces by reducing internal engine friction. Makes everything just turn a little bit easier. One key way to improve fuel economy is to reduce pumping losses. What method is used in many hybrids to reduce pumping losses? Air variable valve timing, Atkinson cycle, electronic throttle control, all of the above. That's all of the above. Number 28. What type of coil ignition system is used on hybrid electric vehicle gasoline engines? That shouldn't be hard, guys. What kind is it? What are you expecting to put on there? What are they putting on just about everything now? Coil on plug, man. Number 29. If a wideband oxygen sensor is used, it may be called a what? Wideband oxygen sensor, lean air fuel sensor, linear air fuel sensor. Could be called any of those, all above. Number 30. All hybrid electric vehicles use what? Coil on plug ignition. When an engine is operating at leaner than 14.71, lambda will be what? If it's leaner, lambda is going to be more than 1.0. You're going to look at your scan tool and you're going to be looking at lambda. And whenever you see 1.0, that's basically just to put in a scale where 14.7 to 1 is 1.0. And whenever it goes leaner, it's going to be more than 1.0. When it goes, richer, it's going to be the other way. So keep that in mind. Don't get confused by that. The gasoline engines in hybrid vehicles often what? A, have a large displacement. B, need electric motors to start the ICE, internal combustion engine. C, both A and B, or D, neither A and B.
B.
What do you got?
B.
32. But that's actually supposed to be B. None of those other ones are right. It's the only one it can be. It's got to be B. During one stroke in a four-stroke cycle engine, the crankshaft revolves how many degrees?
A.
Really?
I don't know.
C.
No, one stroke now.
180 then. B.
There you go.
Oh, 180.
One stroke is the piston starts at one end and goes to the other, right? You got it. The component that connects the piston to the crankshaft is called the what? Come on, guys. Don't play dumb with me.
Did you skip one?
Huh? Did I skip one? I'm sorry. I did not even mean to do that.
All right, go ahead. The component that connects the system to the crankshaft is called a...
What's it called? The component that connects the...
I
Huh?
think you want to say connecting rod.
What do you think? Connecting rod. That's, hey, you know that. All right. Now then, technician A says the Technician A says the Atkinson cycle improves combustion efficiency by leaving the intake valve open longer than normal. That's true. Technician B says this increases effective compression ratio. Which technician is correct? That's A, isn't it? Yep, number 36 is good. Atkinson cycle is just like a regular engine, only that during part of the travel of the piston coming back up, the intake valves are still open. And that sounds counterproductive because it's actually pushing some stuff back into the intake. Well, because it's doing that, they've got to have special intakes with carbon traps on them and stuff. So basically, it's more suitable for that kind of engine to be used on a hybrid than a regular kind of engine. You know, because it's not as hard to turn that engine, and basically it can do the same amount of work. It's being helped by the electric motors anyway. And so it's better for economy. There's a bunch of different reasons they use it. I mean, it seems kind of silly. You know, why in the Sam Hill do you want your intake valves open during part of the compression stroke? That used to bother me, you know, but that is obviously something they've come to enjoy. Technician A says that torque is a rotating force. Technician B says torque may not always cause movement. Is that right? Who's right? C. Technician A says all pistons...
Right.
Huh? Yeah, C's right. You can actually apply torque to something without moving it. Of course, if you're like me and Willie, you ain't never grabbed a hold on it and it didn't move. Ain't that right, Willie? All right. All right. Technician A says all piston pins are offset. Technician B says offset piston pins increase friction.
A.
That's B.
Right, B,
Yeah. Offset piston pins increase friction. All right. Now, I'm going to show you something here right quick before we jump out of here. Because we got this second. My phone's ringing out there and I'm ignoring it on purpose.
I was starting to wonder.
I am.
It's kind of rude, you know.
Not whenever you're in classroom. They should not even call me. All right. Now then, what I'm going to do is I'm going to show you a little bit of just a brief little bit of stuff from this hybrid school. Now these guys right here, this is me and my team here. Huh?